Sandra Santos from the Cultural Gallery is one of the co-chairs of the museums group, and she is a now two-time member of the program committee and the designer of the tote bag. So a lot of heavy lifting. So I'll hand it over to Sandra, and we'll go through our writing process.
Okay, so first up we have Glen Robson from the IIIF Consortium, and he's going to talk about creating the IIIF backup.
Hi, so I'm going to talk about creating a IIIF backup, and I can say a big thank you to the program committee because it's kind of really situated well with a number of their presentations earlier. So this is kind of inspired by, I run the training sessions 4 times a year, kind of teaching people IIIF. We have a mix of people, both academics and both people working in institutions. But particularly when I have academics on the course, one of the things they ask is, what happens to my research if the IIIF manifest I'm using becomes inaccessible? And this is very similar if you were at the presentation at lunch that Chris mentioned, where he'd embedded his whole kind of course using this manifest from the Internet Archive, and then it became inaccessible. And this kind of IIIF backup is a possible solution for that. Just to situate it in the work of which Leander mentioned, so Leander mentioned about the importance of persistent identifiers. And this doesn't replace that. This is just kind of a backup. So if you should have persistent identifiers, but if you, as a researcher, want to take a backup of a IIIF manifest, then this might be a possible solution. And this is echoing, again, what Leander was saying earlier, that the IIIF presentation recommends that all manifest identifiers and URIs should be as persistent and unchanging as possible. So when you're setting up your IIIF implementation, you should be making a commitment to make sure that those identifiers for your manifest are persistent and unchanging. But of course, we all know this can't always be the case. So there are many institutions, particularly cultural heritage institutions, which are being affected by cyber attacks. So the British Library is a big example. Also, the Internet Archive is another example where all of the content was inaccessible, but also all the IIIF manifests and the people who were potentially using were inaccessible for a time. So the question is, what if you could create a backup of the manifest you're using? And potentially, the use cases for this is you could have a backup, so you could publish a replacement if the manifest became unavailable. So particularly for Chris's use case, he might take a backup at the start of the course, and then in case the live manifest ever became inaccessible, he could have a backup which he could potentially use. Another potential use case is if you wanted to use a manifest for your research and you wanted to publish the exact version of the manifest that you were using, potentially you could use this tool. So kind of a prototype is available on GitHub. It's a Python application. What it does is it downloads the manifest. It downloads any video, audio, or images that are linked, so it works with version 3. And also it works with IIIF images. So if it's a IIIF image, it will go and it will harvest all the different tiles that make up that IIIF image and turn it into a level 0 IIIF image, which is just a simplified version of IIIF image which runs from a file system. It doesn't yet support 3D, Ronald, but hopefully soon. And it zips all these different files into a zip file, and that's kind of your IIIF backup. So this is a command that you can use to put it to a manifest. It creates a zip file and it runs. And I'll talk about the kind of experience of running it in a sec. Then the opposite side of the deflate is the inflate. So this takes your zip file, extracts it to a directory, and you also pass it the kind of the URL you're going to publish it at. So then when you do the extract, it extracts all the files and updates all the links inside the manifest and the info.jsons. So it's using that local copy rather than the version which is from the original. And this is the command line again to be able to do that. And then this is a kind of a short video showing a manifest I downloaded from National Library of Wales. It's only 8 pages long, but you can see that the link has been updated, so it's a version which is served from GitHub Pages. You can serve it from many different things, so GitHub Pages is a free way of serving websites, but you could also do it through AWS or any Apache web server or web space. And you can see as you're zooming around a particular image, all of the image requests are coming from your local copy rather than the live image server. But I do want to be honest and say the harvesting was very slow. So it was only an 8-page manifest, and it took about an hour. Because if you think about it, it's downloading each of those individual tiles for those 8 images, which means there are an awful lot of images that it has to download. I thought it was going to be very big, but it turned out for this 8-page zip file, it was only 11 megabytes. So the size of the archive isn't very big. But I do need to have a look at making it easier to use. One of the things I wanted to do is to use the image API to create this level 0 image server, which, because I'm a IIIF geek, was really technically interesting. But I think in practice it might be best just to download the highest quality image and then create the level 0 kind of locally, which will reduce the number of requests and probably make it much faster to use. So I'll definitely be having to look at that. I'm also hoping to make it easier to use. Potentially make it a GitHub action, so you could put it in there to harvest your manifest to make it easier to use. But there are some file limits in GitHub, so we'll have to see how that goes. And I also want to look at more complex manifests, so manifests with annotations, potentially multiple images. So hopefully it can be that kind of temporary use case, particularly for the researcher, for people that want to use content in their courses. They have the reassurance that they have a backup that they can use in case the live one goes down. But with the kind of speeds it's showing, it's never going to be useful to be able to harvest somebody's entire content. But hopefully it's going to be useful to the individual researcher, which wants to make sure that their collection that they want to use is available and they have a backup for future use. So, thank you.
So next up we'll have Appleby from Yale University talking about digital collections AI, LLMs for IIIF digital collections.
All right, there we go. Can you hear me okay? No. No? Uh-oh.
Oh, it's not on. Sorry, I turned it off so we wouldn't hear it rustling over your hair.
No, there we go. Oh, that's odd. Okay, yell if you can't hear me. So yeah, I'm here to talk about a tool. It went out again?
What happened? Oh, it's off. Hold on. Oh, you're good now.
Okay, all right. All right. Here to talk about an experimental tool that we call Digital Collections AI. This was developed about a year ago, and we were thinking about how to use large language models with textual content from images in our digital collection system at Yale. This was very much an experiment, and we faced a couple of obstacles in just starting to think about this. One is that we wouldn't want to build code into our digital collection system directly. That's just an experiment while we had other work ongoing, as we always do. So we didn't want to get in the way of ongoing development. The other is that we have about 6 million images, and maybe half of them have some form of OCR available. So if we were going to build a tool that could work with the text, we would have to perform OCR or HTR on the other images, but we didn't have any mandate or funding to go just do the rest in bulk. So this led to thinking that we would perform that text extraction on demand. In other words, when a user went to an object and asked to interact with it with an LLM, that's the point where we would actually spend a few cents to perform the text extraction. So those kind of strange constraints led to thinking about building this application as a separate standalone application, separate from our digital collection system, that would use IIIF and essentially be a IIIF client to our digital collection system. And a byproduct of this means it will actually work with any other IIIF site. So what we're using is IIIF, obviously for the image retrieval, manifest retrieval, and then Amazon Web Services Textract, which is their text extraction service. Google and Microsoft have equivalent services in their This is not aimed at historical text extraction from historical documents. It's really aimed at modern day business cases, but it actually works surprisingly well for our needs. And then for the language models, we're using AWS Bedrock, which is their branding for their AI services to access the Anthropic models, Claude, and Azure for the ChatGPT. So in practice, what this looks like is we have one piece of minimal integration in our digital collection system, that gray box below the universal viewer. If you're logged in and your ID is authorized to use the tool, there's just a link that says open the Collections AI tool in another tab. And that just passes the manifest URI over to the new application. At that point, if the tool does not have the text available, it will retrieve the images in parallel as quickly as we dare push our image server and send them to TextTrack, which is actually very quick to process the images and in turn the text. So there's a delay. But it depends on the size of the work, obviously. The vast majority of our materials are under 50 pages, and we can retrieve the images 6 or more at a time, so that the delay is noticeable but not intolerable. Once that's complete, a new interface opens up, and you'll see this. Again, very MVP, very experimental, but at the top right, there's a drop-down where you can select the language model you're going to use for analysis, and then on the right-hand side, there's a list of prompts that can be filtered and favorited and so forth. And when you click on any one of those, the prompt is bundled up with the text and sent to the LLM, and the results are shown in the main panel. So the goal of this tool is just is not to create metadata that's going to be stored for all time, right? It's to provide some more information about the text than the user might have in the catalog. So in this case, we've asked for personal names in this 35-page journal, and there are a lot between the articles in the journal and advertisements and so forth. And you can see it's extracted a very long list of names that are found in the document. We can perform, and of course this is print material, right? So much easier to extract text from. What was actually surprising is something like this early 19th century travel journal feeding this through. The text extraction quality is very low. The large language model is actually able to extract a fair amount of information from it. The catalog record for this, which is a journal of someone who was doing a sort of grand tour through Europe down to Italy, names several countries and maybe about 10 cities. But you can see already in the first half of the journal that's been analyzed here, we have more cities and countries named than were in the catalog record, right? So I think we're succeeding in providing more information about the object through the use of the LLM. Of course, we can move beyond entity extraction to ask the LLM to provide a bit more analysis, right? So in this case, we asked for names of literary works in this essay by Voltaire from 1776, it's print material, and context. So you can see that it's identifying plays by Shakespeare and other authors, but then it's also giving a one-sentence synopsis of why that work is being mentioned. So as because we have the language model, we can start to ask more interesting questions. We can ask for a summary of the document. Now, text recognition is a problem, right? Eventually, it's just not going to work when the handwriting is sufficiently different from the modern examples that TextTrack has been trained on. Here's a French poem, late 19th century. We ask it for stylistic analysis of that. And number 2 there, it points out that there's a rhyme scheme, but it also indicates that it's kind of it isn't certain because of possible errors in the transcription. So there are a bunch of limitations around this. Text recognition is a limitation. Text length is a limitation. We can't really go beyond 50 pages or so without the potential of overrunning our context window, depending on which model we're using. And then guardrails are also an issue. We have content that's, the language models deem offensive and refuse to answer questions about. So that's another thing we get around to. And I think I'm at time, so thank you.
So next up we have James Misson from the British Library, and he's presenting viewing collections chronologically with IIIF timeline.
Thanks. Yeah. Hi, I'm James Misson. I'm a research software engineer at the British Library, and I'm showing you a tool called IIIF Timeline, which allows you to visualize a collection chronologically along an axis. I can't take credit for the idea of a timeline. I think it first came up in conversation with my colleague Sia, who's somewhere in the room. And then when I started looking into it, it seemed like other people had the same idea too, because in the cookbook, there's this recipe for navigation by chronology. And this describes the use case saying you might want to have a IIIF object presented in a timeline or calendar feature. And then this recipe shows a collection containing 2 manifests, both of which have very specific dates. And if you're new to collections, these are basically IIIF's way of gathering together many manifests. So despite this mention of a timeline in the cookbook, there wasn't, to my knowledge, any existing timeline viewer. So this is kind of a first foray into what that kind of interface might look like. So when you go to the website, you'll see this loading box, and you can either enter a collection URL in the input field, or you can select one of the examples. So let's load up this second one, which is a collection of scrolls, all of which contain the same work, which is the Lotus Sutra. And when we load that up, you'll see that the interface has UV, Universal Viewer, in the top panel, and the timeline in the bottom panel. And you can hover over the items of the collection to see their thumbnails. And then to view one, you just click it, it opens up in UV. And then you can navigate to the next manifest or the previous one with these buttons on the side. And you can click and drag the timeline to pan backwards and forwards in time. To zoom, there are these zoom buttons in the top left, but it's a lot more fun to use your scroll to zoom, and that'll just zoom into wherever your mouse is positioned. So it feels a lot like using Universal Viewer if you've ever used that. So when you load a collection into the timeline, it's going to analyze how specific your dates are, and it will adjust the maximum zoom level accordingly. So that means that if you only have years associated with your items, you won't be able to zoom in further than the year scale. But if you have more fine-grained time data, like in this collection of journals from the Welcome collection, then you'll be able to zoom in much further, in this case, to the days of the week. So in theory, this zoom could go in even further, depending on your data. So if you know the precise milliseconds that a scribe finished one of your manuscripts, then please send me that manifest. So what do you need to use the timeline? You just need a collection that's hosted online somewhere. And if you use the one in the recipe that I mentioned as your model, then you'll be good to go. That's kind of the bare minimum. So the key thing is this nav date property, and this is a very specific time and date string. And that means that material that doesn't have these specifics along with it, so things like conjectured dates or date spans, they're not really going to work for the timeline. We need things more like colophons of printed books or dated letters of correspondence. And if you have any material like that, then I'd love to work with you and get it loaded into the timeline. So the other relevant bit is this label property, and this is what gets displayed in the timeline interface. And this is where you can be a bit creative with your timeline, because this doesn't necessarily have to be the same as the label within the manifest. So let's say I was teaching a course on print technology in Europe, and I had gathered together several manifests from different institutions, each of which represents some sort of milestone in print history, like the first book printed in English or the first book printed in italic type. I could put these descriptions into this label property and get a timeline like this one, which shows these milestones in the UI. And this is going to be much more informative and educational than simply using the shelf marks of the book's titles. So when you're happy with your timeline, you can share it just by pasting the URL, and that's going to embed your collection and any settings that you've changed as well. Or you can click that middle button in the footer, and you'll be given a HTML snippet, and you can paste that anywhere into your web page. And the International Don Juan program has very kindly demoed this embed feature. So C has written this paragraph about the Lotus Sutra collection, and then below it we have the embedded timeline. And if you check it out, this website also has a feedback button, so please give me some feedback. So what you've seen so far is a very early iteration of the timeline, and I'll be continuing to make improvements, like making it more mobile friendly, making it more accessible. I'm also thinking about what features to add next, including something like this, which would allow you to add events and date ranges to your timeline. So we have some dates represented by the yellow dots there, that fall of Constantinople, and we have some ranges with the coloured brackets, like the laws of the roses. And this is really to set your IIIF material within a historical context. So until then, let me know if you need a hand getting started with the timeline, and shout out to Erin Benand, Sia, and Julien Cook for your support with this project, and thank you all for listening.
Okay, next we're going to hear from Niqui O'Neill from Stanford University about inching toward content state. Thank you.
Hi, I'm Niqui O'Neill. I work at Stanford University Libraries, and I'm going to be talking about a recent decision we made about looking at adopting content state. So as you can see on the right, this is an example of Stanford's Spotlight instance, which we call exhibits, which has widgets that allow exhibit creators to embed a Mirador viewer into a web page. We received a feature request that asked for allowing users to zoom into a portion of this Mirador viewer, be able to save it, and have it display on that web page. I'm assuming anyone familiar with content state will say this sounds familiar. What we needed was content state. This feature ended up going through multiple devs. I was not the originator. My colleague Marlo Longley was. He's much more familiar with Mirador's code, and he's actually the one who told me, because I was pushing for content state, that content state was not going to be doable. The way Mirador was built was it expects a manifest or a collection URL. Using content state as the data source was just going to be a no-go, especially within our timeline. So what did we do without content state? So we ended up adding an option into Mirador called initial viewer config, which basically takes, if you see the red box, that's an export. So those familiar with Mirador, you can export a workspace. It basically takes those coordinates from Mirador and allows you to put them into a initialization of Mirador. We also ended up creating a plugin that will convert OpenSeaDragon's coordinates into an XY with height coordinate, because we needed that for this other screenshot. You can see there's a thumbnail. We needed to be able to update that view. So this is a video of us, the actual in production example. So they can open that modal, go to a page, zoom in, save it, the thumbnail will update, and you can say save, and if you actually look, it will load and it will be in that zoomed in state. This also works across multiple pages, so those familiar with Mirador you know, you can show a book. So if you're looking at a book and you want to show, oh, that's the first one I showed, sorry. It's just another example. So just gonna let it go through because I know I did this video a little fast. So here's another example. That's a 2-page Mirador. You can see it saves. You can see both thumbnails, and it will save with that view. There we go. Most viewers were built before content state existed. As new features come out, especially new data sources, we really need to engage the larger community, especially devs, about either buy-in or ways to not stress these complex systems. Because right now, if you look at this screenshot, you can see that none of the viewers actually use content state. And it's been out for a while. And I don't think that's just because people are unaware of it. It's because getting it into a viewer is incredibly complicated. If you have any questions, that's my contact information. That's it for me.
Thank you for the long title, Julien. So, Julien Raemy is going to talk about a sustainable commitment, balancing IIIF keyword enhancements with streamlining measures at the Swiss Federal Archives. And he's coming from the Swiss Federal Archives.
Thank you, Sarah. Yes, sorry for the long title. Is it working? Can you hear me? Yes, so I will share how the Swiss Federal Archives has been implementing IIIF in different portals. Some of the great stuff, but also mostly the challenges that we are now facing. We started to implement IIIF in a very small project called the App Transit Portal in 2018 with the image and presentation APIs. The project is still running, still a website, but very specific. Then we moved on to the Minutes of the Federal Council platform, so a dedicated platform where HDR and OCR data are also available through the content search API here. And finally, to our main platform, so where we have the records, so the metadata, but also when we have the digitizations and when there is no problem to share there anymore, then they can be accessed through that portal. Okay, so the first significant, I would say, implementations was the second platform, the Minutes of the Federal Council, so basically the minutes of our ministers. And we have the so-called companion window features that allow users, and I think you're going to see now in the video, to allow users to view handwritten and typewritten documents side by side onto our viewer. So first, just a normal search, when you click on it, then there is Mirador is instantiated, and you have on the left-hand side the document itself, and the right-hand side the window where you can also go line by line. And we, so it's actually a customized Mirador 3 plugin that we made available through npm.js, but yeah, not really being used everywhere else in the world. So that's one of the challenges. Right? And it's Mirador 3, not Mirador 4, also something to take into account. And then in 2023, we extended the implementation to our main portal, also image presentation and content search APIs. And by last October, what we decided to do is also the possibility for people, so that's the archival tripper viewer, which opens then after Mirador, and you can navigate through at the manifest and also at the collection level in your search within the viewer. So don't really have to worry if they go through a very complex archival structure. So, now the challenges. I hope you can, no you can't really read that, I'm sorry, I should have made it clear. I'm going to read. The thing is, those three implementations, 3 different content observers, 3 different viewers or instances actually, and they're actually clones and not forks, or so very, very hard actually to maintain. And yeah, with the release of Mirador 4, something that I told my colleagues, it'd be great to migrate that there, but also it's an opportunity to collaborate within broader IIIF community. So that's one of the things, and to be not only open source, but truly community oriented. And yeah, some of the lessons that we learned is that now we have those 3 isolated innovations. They may be IIIF, but they're not that great in terms of sustainability, and we do have some kind of technical debt and some missed opportunities. So I hope that we can do better in the future and be more involved within the community. And that's the last slide. You see, I'm not going to bore you very long. That's the first thing we would like to do, is to migrate the window to Mirador 4 as an official plugin, as it speaks, to have more involvement in the community. And that's maybe the hardest part, I would say, is mostly it's done through third-party firms, but also that they could engage also with the community workflows and code reviews and be part of, let's say, Mirador call, for example. So yeah, that's my call, not only to my colleagues, but also to you. Please be more part of the community. Thank you very much.
So next up, Matt Jordan from Northwestern University will present more ways to integrate and share with IIIF APIs.
This is the
Hi, yeah, I'm Matt Jordan. I'm a developer at Northwestern University Libraries, and today I'd like to give you a short tour of 2 new features that extend usage of IIIF APIs in our digital collections. One way is focused on users who are maybe aware of what IIIF is and want to extend those resources, and another where, admittedly very experimental, the user is probably not even aware that they're using a IIIF specification. So here's a trimmed down view of a work in our digital collections. It's very simple. It's a photo of the blues and R&B singer Big Mama Thornton. This photo is represented by a manifest and rendered to the user in our Clover IIIF viewer, which is in our digital collections. What you see here adjacent to that photo is that we have introduced 2 new actions that make it easy for users to interact with the item they are viewing, a share button and a view as IIIF button. The view as IIIF action is not necessarily new, but it is rather has been reorganized and elevated to the position on the page that is closer to the viewer in the media that the IIIF viewer is representing. And when that drop down is activated, you'll see sort of the basic things that you would expect. You know, you can now see that you can open this in various viewers. We've got Clover, Mirador, and Theseus, and complete with some JSON options. While this is not necessarily novel, being on a work that is represented by a manifest, we also have decided that anywhere we have IIIF material on a page, we are going to be able to represent that material using this view as IIIF button. So if you're on a collection, you get a IIIF collection, but we don't stop there. So this is a search screen, and we have brought the view as IIIF button to our search screen. Now we have been serving out IIIF collections from our search API for a very long time now, but users weren't aware of them. So here on this page, you have 7,500 results for the map of Africa. And because our digital collections is constructed around IIIF APIs, this allows the user to directly access these 7,500 results as an on-the-fly IIIF collection using that View as IIIF button. I'm going to give you a quick demo here to show like the full user workflow of this. So user here has searched for Ira Aldridge. He's a 19th century thespian, which returns a little more than 1,000 results. They're going to facet or filter on genre and photographs, and they're going to whittle that down to 105 results. And they seem to be closer to what they're looking for, so they're going to go over to the click View as IIIF and open up those same 105 results in Theseus. And there they are. And Theseus is cool. Yeah, we can open up these results in various viewers, in workbenches like Mirador and Theseus. But we can also use this search API on our screen and allow maybe a digital humanities librarian at our library to sort of curate their own collections for their digital humanities projects. So here's an example where that same 105 results was spun up in Canopy IIIF, a static site generator built on IIIF collections. So honestly, the purpose of these actions and the results in those search results could be anything, but the point is that these collections are not defined by us, the provider, the institution, but by the curator and the user. So we were still missing something related to users, and I mentioned earlier the share button, and Niqui just mentioned it as well. But imagine you are a researcher and you have found this lengthy scrapbook with material related to Ira Aldridge, and you know that Mr. Aldridge sort of traveled around Europe during the 1800s, and he performed in the Ottoman Empire. And in this photo, you have found evidence relevant to your research, and you have zoomed in, and you may want to share this exact point at this item you're reviewing with a colleague, or simply save it for later for your notes. Now, in the past, you probably somehow saved your URL, you made a note that says page 32. It's not actually page 32 because it's page 32 recto, it's actually the 64th canvas. So, you know, it's not actually important to a human, but, and you're in the upper right corner and you want those notes. Well, you could put it in a spreadsheet like that, or, oops. You could put it in a spreadsheet like that, or no, I didn't do it. I have to restart that video. Or you can click this share button that is adjacent to that image, and it'll bring up a share URL. Now, by default, it's just going to be the same exact URL the user is at, but there's an option given for the user to jump to that current image. Also an option where they can zoom to the current view of the image. If they were on a video, it'd be the current time, and they can add a note, and in this case, they're going to add a note, Ira Aldridge as a fellow at Constantinople 1860s question mark, because they want to verify it with their colleague, and they're going to copy that URL, and yeah, you get this. And it is ugly, and it is sort of scary, and it's base 64, and I don't even know what that means, even though I'm a developer. But I'm also pretending to be a professor right now, and I actually don't care. It just works. And that URL is actually this. But what is it? It's IIIF content state. But what is content state? And it took me a long time to figure this out, years. But at the end of the day, content state is simply an annotation. And it's an ephemeral, lightweight one that can exist entirely within a URL, or BD referenced as well. And in this case, created on the fly by any user of any background, and they don't even know they did it. They just want to send a link to the friend. But what did they actually want to send? They said they wanted to say, hey, this canvas is my page of this manifest, which is my scrapbook, and this is my view of the screen, and this is the text. And then the user that they send it to will open it up, and they will see this in Clover in our digital collections. Just note that you'll see the annotation was included as part of the user-authored shared link. That's something we append underneath the body so that we can make sure that this is not like an annotation that we have provided out. So while ultimately complex, the end user simply clicked a link and arrives at our digital collections to see this. And the item open to the exact canvas at the specific X, Y, width height coordinate, whatever, with a textual annotation. It's a shared link, an annotation, yes, but to the user, it's just the colleague saying, here's this thing for our shared research. And again, I just want to follow up. This is made possible because Clover IIIF is able to support content state. And it does so in a sort of an interesting way. As I was building it, I wanted to be able to both encode and decode content state in both directions. So as you are scrolling around or pan zooming around, the content state is actually being updated live, and that's informing our digital collections of where we are in the OpenSea Dragon viewer or in a timeline or in a time in a video. And that allows the digital collection to sort of be dumb about it and just take that whatever Clover says and say, okay, well, the user wants to share a link, let's just add a body to it. And I want to say thank you to Julien and Mike Appleby for sort of helping contribute to content state in Clover, and also to Stephen Fraser for his helpers that have made it very easy to support content state in Clover. Thank you.
We're going to have one more lightning talk, and then we'll have a bit of time for Q&A before Glen wraps up and gives directions, etc. So we'll have Matías Butelman from Bibliohack, and he's talking about building sustainable digital heritage infrastructure in the global south. Thank you.
Is this working? Hello? No. Well, before anything, I want to thank the committee for awarding me the scholarship, because if not, I wouldn't have been able to come here, because I'm from there in the south, Buenos Aires, Argentina, South America, the Global South, whatever, many ways to refer to these countries that are not in the center. And this story particularly starts in this school, which looks like kind of monumental because it's one of the oldest high schools in Buenos Aires and in the country. It's called Colegio Nacional de Buenos Aires. And this is where, while I was working as a webmaster, the director of the library tasked me to build a digital library for this secret room that had like special collections. And naturally, it's not in the plans. It's like you have to go through. It's a weird place. It's looked like that for like 100 years. So basically, if nobody touched it, it's still preserved. What you're looking at are like a bunch of 19th century periodicals published in El Río de la Plata. So we had to digitize this stuff, and we thought, why don't we buy this device? The National Library has it, or maybe one of these, or maybe this one that has a robotic arm, or maybe this one that also has 2 cameras, or this thing which I don't understand very well how it works, or maybe this one that is really versatile, and or maybe this big machine. I saw that one in Harvard once, but it has a very special camera. Anyway, these are the prices, and most of those are more than the usual budget any kind of organization where I work has for a full year. So it wasn't possible to acquire any of these machines that were targeted specifically for cultural heritage digitization endeavors. So we said, why don't we build one? This is like a design my partner in Bibliohack, Juan Pablo, started working on like 10 years ago, and this is how it looked when it was built. It has a structure. It's more of a sticks and stones approach. but it looks in a way like the other ones because it has lights and cameras and the flat in there and the cradle for the books, and the cradle is adjustable, and the lights are cheap because they are consumer grade equipment you can get like in the hardware store. The cameras were pocket Canon cameras that had been modified, like all those messages there is because there was a community developed firmware called CHDK, Canon Hack Development Kit, that allowed those old cameras to be remotely controlled and shot at the same time. This was a common approach, you see 2013, like 12 years ago. In many, there was a big community behind that because these features were locked in the firmware. They weren't available if you simply bought the camera. And we developed this command line script with Lua that could talk to the camera and CHDK. And basically, we could replicate at least the basic function of one of those lots of dollars scanners. And this is the device in the library. It worked. We would generate some pages and then process them with open source post-processing software. And then we built some other iterations of this same design that worked, but they also had its problems. So we started developing a more focused approach with laser cut parts that generate this kind of stuff, and then produce like this more robust and sharp looking in a way device, which is kind of more structured, more similar to the commercial ones. You see, this is the final version. It's like a bit more serious, less stick and stone. Then we try to replicate the copy stands, which are a very complex thing because you say, why do you need a copy stand for paper if you can use just a tabletop scanner? Well, there are some considerations regarding how you illuminate the paper or whatever. So then we started doing the same for this type of device. Oh, sorry. And we had some iterations too. This is in Buenos Aires Modern Art Museum presenting the invention. And there you see it working also with a pocket camera connected to the computer. And this is a variation. And then we have another variation that looks like the one at the end. And there you have it in progress, trying to work with some kind of architectural plan. And there you see it in Memoria Abierta, which is a human rights documentation center in Buenos Aires. This was a UCLA Modern Ancient Archives funded program. And it worked. I mean, the camera in this case was a DSLR, and it was still controlled from the computer with tethering, with a tethering software. And this happened like for 5 or 8 years after the first device we built, and then with the pandemic and a lot of complications in Argentina, we suddenly hit a wall. We could experiment with these open source approaches to hardware, but we discovered like the main problem with these things is that maybe you can build them and they are cheap and the resources are available, but if you can't make the library or the archive stuff and use it and incorporate it into the common workflow, then it's a very nice sculpture, but it doesn't produce sustainably. It doesn't sustainably produce like enough documentation. It doesn't work really. They needed us to be present. So basically, these are the reasons we detected. Like it's difficult to set up. If you involve like command lines and firmware and a lot of tech vocabulary, most of our potential users wouldn't simply adopt it. And when we left, like the pandemic caused us, we couldn't visit most of the places. They just stopped using them, and then the stuff changed, and there they are, most of those devices. So we thought that we had to embed the usability and maintainability in the devices just to allow them to work, such like most of commercial devices work. You just buy them, and the software is more or less okay, and it has enough features for these to work in an office and maybe even in cultural heritage contexts. But if we wanted to push the vision like forward, like if we wanted to build a fully open source device for cultural heritage, we needed like another round of development. But that's where we are today. We need to make the structure like a IKEA flat pack. Like you have to be able to build it. So that's when you buy a table or whatever. It has to be modular, have fewer parts. It has to be lighter, stick together with like a screwdriver, and allow you to like pull the cables through the specific channels. The lights can be probably replaced by affordable LED panels. At least there is a spectrum of documents that do not need higher grade lighting, like photographic professional lighting. So there is basically a huge amount of documents and pages that can be successfully digitized with this kind of approach. And if they burn, you can just go and buy another one, no matter where you are, and replace it. Cameras. We can try to remove the vendor and use whatever is being used with, I don't know, in drones and industrial machines. This was, in fact, done, I think, in some devices used in one of the early Google books, trials, by a Russian inventor. But the thing is, it's the same with the lights. You can use these kind of sensors to basically generate acceptable preservation grade pages in many cases, and this would drive the prices even lower. And then the real challenge is the software. We don't just need to control the cameras and shoot them and change them, but we need to be able to control the settings, even with predefined capture characteristics. We need to be able to get the live feedback through the screen, so the user can effectively know what's being photographed. The automatic processing after the capture can be done by already available image modification scripts, the image adjustment, I mean. And the quality assurance can be, in a way, at least in a certain point, automated. And, well, the metadata management can also be streamlined, because if there is already an available database, the software could like import the data of the book being captured and carry it till the end. So when you get the pictures, you also get at least a minimal amount of metadata that will travel with all the image files. And basically you can end the process when you are operating the device with a package already available to be imported into different kinds of systems. If that were modular enough, you could just plug in different export profiles to get the images in the ready state you need, maybe even for IIIF sharing. And that's our adventure. Thank you.